This video will be solving second problem of the Leetcode, add two numbers. So this is the linked list problem in which we are given two non-empty linked list representing two non-negative integers, and the linked list is given in the reverse order, and each node in the linked list contains a single digit from 0 to 9, and we has to add these two linked list and return the sum of these two linked list. So for example, if our number is 3 4 2, the first linked list that is given to us is 2 4 3. That's because it is given in the reverse order that's mentioned here. So 3 goes here, 4 and 2, so it's the reverse of 342. Similarly, second number that's given is 465, but it is again reversed, so 465. Here we have the head of the linked list, and once we add these two linked lists, our resultant sum will be 807. So resultant is also required in the reverse order, 807. That's how we has to solve. Again for this summation, here we have the head, and 708 are the elements in the linked list in forward order. Similarly, we have other inputs also. 0 0, resultant will be 0. This is an example which is given specifically to stress on the fact that we can have carry also at the end of the summation. So that's why it has been given. So we will see more examples and see how we can solve this problem in a different window. If we forget about the linked list problem and simply see how do we add two numbers in mathematics, then we'll get the idea. So let's take the first example. First one was 3 4 2 and 4 6 5. So if we have to add these two numbers, how we'll do? We'll start from the least significant position, which is the 0th place, and it gives us 7. Then we move further to next position, 10th place, it gives us 0, and then 1 is the carry, and then we move further and consider the carry also, then 7 and 1 8. So this is the sum of two numbers. So what we did, we start from the very least significant position, and then we went ahead, 10th place, 100th place, 1000th place, and so on. So we need to access the 0th place element first, and then the 10th and 100th and so on. So we need linked list of the kind, because this is a singly linked list. We need head, and we need the elements in the reverse order, 2 4 3. Then for the second list, this is the head, and we need elements 5 6 and 4. And then similarly the resultant will be, I'll calling it R, although this is the head itself. Then resultant will be 7 0, and then 1 carry also, then 7 plus 1 is 8. So that's what we are required. And from the question itself, if we go back, so intentionally they have given in the reverse order so that it becomes easy to solve for us. So simply we'll start from the head of the two linked list, and we'll keep on adding the numbers between the two linked list, considering carry also. Like here we saw we got carry also, then this carry should go to the next position, and that should be considered while adding. So this was a case when there was no carry after the both the linked list has ended. We can take another example where it will leave the carry at the end. So 5 1 2, and we take 6 2 3. So here in this case it will be 5, then 3, then 5 6 will be 11. So 1 and 1 carry also. So this is the carry which may cause problem. So to solve this, what we'll do, we'll again take this linked list in the reverse order, then 3 2 6, then we'll add, it will give us 5, no problem, 3, no problem. Yeah, now it will give us 11. So let's take this 11 here. So first we'll take 1 from it, remainder 1 from it, which can be taken by modulus operator. It will give us 1. And then we'll take this carry also. So this one which is coming from the modulus will go here, and we'll left with carry also. Carry is also 1. So in code we'll check if our both the linked list has ended. Still, if we have some carry, then we need to add this carry also. Then this carry also gets added here. So we'll handle this special case in the code. So now again going back to the Leetcode to code this up. As we saw, to solve this problem, we can traverse the two linked list and keep on the tab for the carry. So here we'll take two pointers to traverse for two linked list, L1, L2, and then we'll take resultant linked list also. So we'll create a head for the result linked list, and we'll create list node of -1. So this is a dummy node that we have created, and in the end we'll return head.next, and head.next has the all the digits that are for the summation. We'll take carry also, which should be 0 initially, and then we'll run our loop. So it will run either L1 is non-empty or L2 is non-empty, or we have some carry pending, and not exactly L1, L2, P1 and P2, because we have taken reference to traverse the both the linked list. Now we'll check if P1 is not none, then we'll do val plus equal to P1 dot val, and P1 is equal to P1 dot next. We'll move P1 forward, and we'll take val equal to carry. Whatever is the carry from the last digit summation, it will be present in the carry. We'll update this carry in this loop itself. And if similarly for P2, we'll do P2 dot val and P2 equal to P2 dot next. Now we'll create a new node which is resultant of it, and it will be equal to okay, we'll take a pointer to traverse our resultant also, because we keep on adding the numbers and we has to move forward also in this. So 7, then that's why we has to keep track of this one also. P dot next will be, we has to create a new node, and then its value will be val and modulus of 10, and then carry will be, will divide by 10 to get the carry, and we has to enhance P also. P equal to P dot next, and in the end we has to return head dot next. So that's why we took a dummy head, so that after this we keep on increasing this pointer, and in the end we should get the result. So that's it. So carry is, let's say my both P1 and P2 is now empty, and but my carry is still present. So that's a last case. If we add these two at the end also, we'll have some carry. So it will be run the loop one additional time. So let me Run this, take all the examples, run this code, tran, I'll submit. Yeah, so it got accepted. Now let's talk about the complexity of this algorithm. So this is what defines the time complexity. So we are running till P1 or P2 is empty. Let's neglect this. If the carry is present, only one additional time it will run at the end. Otherwise, this P1 and P2 are the deciding factor. So it will run until, so let's take a example. Let's say L1 has number of elements equal to 3 elements, 3 nodes, and L2 has 5 nodes. So looking at this OR condition, it will run till all the nodes of L2 has been traversed. Although L1 is a lesser number of nodes, but it will run still to cover all the nodes of L2. So that's why the time complexity of this algorithm will be max of M and N. M and N are the lengths of two linked lists, L1 and L2. So this is the time complexity. Now space complexity. Space complexity will also be same because we are allocating a node here, and this is totally dependent on the number of times the loop runs. So we are consuming space also proportional to the time. That's why space complexity will also be same. So we have taken one extra node here. So this is outside of the loop and independent of the lengths of the input. That's why these things are considered constant, and we don't take this while calculating the asymptotic complexity of the algorithm. So these are the two complexity, and both are same order of max of M and N, whichever is the maximum between the two linked list. So this is the iterative way of solving this problem. We can solve the same problem using recursion also. So in that case, what we'll have to do, let me just revert this. What we'll do, in the end, we has to return the head of the resultant linked list, and another challenging part is that we has to keep track of the carry also. So to keep track of the carry also, we can add another optional parameter to the same function, or otherwise we'll have to create a helper function. So I find this helpful because we just has to add an optional parameter. So whenever Leetcode runs the test case, it won't send this equal to any parameter, and for us we'll send that. So what we'll do, we'll take this val again equate to carry that we are getting. So let's call it carry, and then condition will remain the same. It's just that we have to tweak the problem a bit. So again, if L1 is not none, we'll do plus equal to L1 dot next and advance L1. Similarly, if L2 has some elements left, val equal to L2 dot next and L2 equal to L2 dot next. Now before calling this function, we has to check if we need to call this function further or not. So we'll only call this function if we have some elements left in L1 or left in L2, or we have some carry left over at the end. We'll also create the new node, which is list node of val percentage of 10 to get, and then here we'll do node dot next equal to self dot add to numbers, and we'll call this with L1 and L2 and carry. So we has to update the carry also. Carry equal to val 10, and at the end we has to return node. And yeah, I think we should be done here. We have taken the node and we have updated the carry, and then this is the condition. Yeah, so let's just run this one also. Unsupported operand, that's because it has to take val, not the next pointer. Yeah, submit. Yeah, this is also accepted. So for this one also, everything remains the same. It's just that we are using uh, recursive instead of iteration. Time complexity, space complexity remains the same. But for this specific problem between the two approaches, I'll say iterative is better, because in most of the solutions, recursive solution gives some additional benefit. Code becomes simplified, but in this case, I don't see any additional benefit of recursion, and time space complexity remains the same. So I'll go with iterative approach for this specific problem. So that's it for this video. See you in the next one. Thank you.